Hello friends, in today's question, two identical cylindrical vessels with their bases at the same level, each containing a liquid of density rho. The height of the liquid in one vessel is h1 and in other is h2. The area of either base is A. What is the work done by the gravity in equalizing the levels when the two vessels are connected? Okay. So in this case, we are given two vessels and they are interconnected. Let's draw the rough approximate diagram. The height of the liquid in one of the vessel is h1 and another vessel is h2. Okay. So this is the interconnection between the two vessels, and we say that h1 is the height of one vessel. It is cylindrical basically, but I have shown something like a tube, and another one is your S2. So obviously, as the density is the same, when they are interconnected, they will be attaining a common height. Okay. So we have to find out the work done by the gravity in equalizing the levels when they are interconnected. So in this case, for work done, we are going to find out with respect to the potential energy. We are going to find out initial potential energy and we are going to find out final potential energy, and that their difference is going to give us a work done by the gravity. Okay. So let us start when we have two identical cylindrical vessels. Okay. And find out what will be the equilibrium height, and then we are going to proceed further. So we are given that in initial setup, we have two identical cylindrical vessels. Two identical cylindrical vessels with liquid density is given as rho, with liquid density is given as rho in both the vessels, and we have height of liquid. It is given as h1 and h2, and it is also given that the base area is A. You can say base area is given as A. So first of all, let us find out what happens to the height when both are connected with each other. Okay, and we call that height as a final equilibrium height. Final equilibrium height. So as soon as both the vessels are connected with each other, the liquid will flow until the height of in both the vessels becomes equal. So we say when the two vessels are connected, the liquid will flow until height in both vessels is equal, and let us call that height as HF, that is final equilibrium height. Let us call this HF. So HF will be equal to the mean of two heights, h1 plus h2 divided by 2. So this will be the final height of the liquid. that will be attained in both the vessels. So you have to keep this in mind. And let's find out what will be the, we can say, initial potential energy. So initial potential energy will be our, we can say, potential energy with respect to first vessel plus potential energy with respect to the second vessel. So for that, let us start with the volume of liquid in each vessel. You can say volume of liquid in each vessel. So we say initial volume of liquid in first vessel so let us call that as V1, which will be equal to area multiplied by H1. And similarly we can say initial volume in the second vessel, let us suppose that is given as V2, and that will be area multiplied by H2. Now this was the initial volume. So since as soon as the vessels are connected, the total volume will be equal to the summation of both the volumes, V1 plus V2. So we can say since vessels are connected and no liquid is added or lost, the total volume remain constant. The total volume remains constant. So which basically means that volume before connecting the vessels will be equal to volume after connecting the vessels. So we can say volume before connection will be equal to volume after connection. And before connection we have volume V1 plus V2, and let us suppose volume after connection is given as V total. So therefore we can say that our V total will be equal to, we substitute value of V1 and V2. V1 was our AH1 and V2 was our AH2. So this becomes AH1 plus S2. Let me write it again. So we get V total is equal to, taking A as common, this will be H1 plus S2. So the volume remains constant before and after. Now we are going to find out work done by the gravity. So for first that we are going to find out initial potential energy. Let us start by work done by the gravity, which was our final target. Work done by the gravity. So like I said, that work done by gravity is the difference in the gravitational potential energy, gravitational potential energy between the initial and final state, between initial and final state. Here initial means before connection. So here initial means before connection, and final means after connection. So let's find out the initial potential energy. So you can say initial potential energy, that will be equal to potential energy of vessel 1 plus potential energy of vessel 2. So let us call that V initial as Ui, that will be equal to U of vessel 1 plus U of vessel 2. So we substitute, we get that M1 G H1 by 2 plus M2 G H2 by 2. And we can find out there. Okay, here important thing is that we are finding the potential energy for each vessel with respect to the center of mass, height of the center of mass. So let me write it here, that potential energy of each vessel is calculated using height of center of mass. Height of center of mass. That's why it is H by 2 and H2 by 2. And let us find out what will be our mass. M1 will be equal to A H1 multiplied by rho 1, and our M2 will be equal to A H2, sorry, density is same, H2 multiplied by rho. So therefore we can write our initial potential energy, that is Ui, will be equal to A, and we have, this is rho and H1 square by 2, plus here we have A rho H2 2 square divided by 2. So this is our initial potential energy. Now we are going to find out the final potential energy, and the final potential energy will be with respect to the final height. So let us find out the final potential energy. Final potential energy, and let us call that is UF. And UF, once again we are going to do it for with respect to the mean height or the final, and the final height we have already said is our HF, that is a final equilibrium height. We have already taken it as HF. Okay. Therefore we are going to take its mean, that is HF by 2, and the height in the liquid in the first vessel as well as second vessel will be same. Okay. So therefore we can write our final potential energy will be equal to twice multiplied by mg HF by 2. And we can substitute value of the mass, and for mass it will be equal to area total height H1 by H2, and we have here rho. So we can say our UF will be equal to twice multiplied by, here we get it as we substitute the value, we get this A, and we have here HF V is also equal to H1 plus H2 divided by 2. So let me write it here, H1 plus H2 divided by 2 rho, and this is G, and HF is also our H1 plus H2 divided by 2 multiplied by 1 by 2. Okay, this 2 and 2 cancels out. So we get UF will be equal to A rho G, and here we have H1 plus H2 divided by 2 and its whole square. And this is our final potential energy. Now, the work done by gravity will be equal to the difference in the potential energy. Work done by the gravity, let us put that is given as W is equal to U initial minus U final. We substitute the value now. W is equal to initial, we were having like it was our, this was our initial, A rho H1 square divided by H2. I forgot to write G. Here it is G also. Okay, so this is A rho G H1 square divided by 2 plus A rho G H2 square divided by 2. So A rho G is common here and A rho G is also common here. We can take it as common from the entire equation. So we get A rho G and we have H1 square plus H2 square divided by 2 minus, and we have H1 square H1 plus H2 divided by whole square and this divided by 4. Now taking it as LCM and opening the square, we get this as A rho G, LCM we are getting 4, so this becomes 2H1 square plus 2H2 square minus H1 square minus H2 square and minus 2H1 H2. So we have a 2H1 square and H1 square, so this becomes A rho G, and this comes at H1 square plus H2 square minus 2H1 H2 divided by 4, and this is nothing but H1 minus H2 whole square. So therefore the work done is equal to A rho G, and we have a H1 minus H2 divided by 2 and its whole square. So this was our work done by the gravity. It was asked for work done by the gravity in equalizing the levels when two vessels are connected. So this is the work done by the gravity. This is the work done by the gravity. Okay, that was asked in the question. This completes the question. Thank you.